Hello! In this video, we will use the addition and subtraction formulas for sines and cosines to solve 4 examples. In the first example, we need to find the exact value of the expression sine of 105 degrees, and we cannot use a calculator. So then, if we cannot use a calculator, then we need to work with some recognizable angles from the unit circle. And if we use the formulas above, then we need to write 105 degrees either as a sum of 2 angles from the unit circle or a difference of 2 angles. And notice that using the unit circle, we can write 105 degrees as a sum of 60 degrees and 45 degrees. So then, using the formula for the sine of a sum of 2 angles, which is sine of alpha plus beta equals sine of alpha times cosine of beta plus cosine of alpha sine of beta, we can write the following. Sine of 105 degrees equals sine of 60 degrees plus 45 degrees. Then according to this formula, this equals sine of 60 degrees cosine of 45 degrees plus cosine of 60 degrees sine of 45 degrees. And now let's evaluate each sine and cosine using the unit circle. On the unit circle, each angle has a corresponding point. The first coordinate of this point represents the value of cosine at the given angle, and the second coordinate represents the value of sine. So, sine of 60 degrees is square root of 3 over 2, and cosine of 45 degrees is square root of 2 over 2. So, we will write square root of 3 over 2 times square root of 2 over 2 plus. Now, cosine of 60 degrees is 1/2, and sine of 45 degrees is square root of 2 over 2. Then we will add 1 over 2 times square root of 2 over 2. Now, in the first product, in the numerator, square root of 3 times square root of 2 is square root of 6, and in the denominator, 2 times 2 is 4. So we will write square root of 6 over 4. In the second product, 1 times square root of 2 is square root of 2, and 2 times 2 is 4. So we will add square root of 2 over 4. And now if we add these two fractions together, we will have square root of 6 plus square root of 2 all over 4. So this is the exact value of sine of 105 degrees. In the second example, we will prove the trigonometric identity sine of pi over 2 minus theta equals cosine of theta. So to prove, we have to show that the left side is equal to the right side. And since on the left side we have sine of a difference of 2 angles, we will use the second formula. And this is sine of alpha minus beta equals sine of alpha cosine of beta minus cosine of alpha sine of beta. Then according to this formula, we will rewrite the left side as sine of pi over 2 cosine of theta minus cosine of pi over 2 sine of theta. And we will keep the right side as it is. Then, using the unit circle, sine of pi over 2 is 1, and cosine of pi over 2 is 0. If we replace, we will have 1 times cosine of theta minus 0 times sine of theta equals cosine of theta. Then the left side becomes cosine of theta, and the right side is also cosine of theta. So we just proved that sine of pi over 2 minus theta equals cosine of theta. In the third example, we need to find the exact value of the expression cosine of 49 degrees times cosine of 11 degrees minus sine of 49 degrees times sine of 11 degrees. And again, we cannot use a calculator. The given angles are not special angles from the unit circle. But notice that this expression matches the right side of this formula. And this is cosine of alpha plus beta equals cosine of alpha cosine of beta minus sine of alpha sine of beta. Then according to this formula, we can write the given expression as cosine of 49 degrees plus 11 degrees. This makes cosine of 60 degrees, and from the unit circle, cosine of 60 degrees is 1/2. So the exact value of this expression is 1/2. In the last example, we will find the exact value of the expression cosine of 15 degrees. Again, if we don't use a calculator, then we need to work with some recognizable angles from the unit circle. Notice that we can write 15 degrees as a difference of 60 degrees and 45 degrees. So now we will have cosine of 60 degrees minus 45 degrees. And once we have a difference of two angles, then we will use the last formula, cosine of alpha minus beta equals cosine of alpha cosine of beta plus sine of alpha sine of beta. According to this formula, we will have cosine of 60 degrees times cosine of 45 degrees plus sine of 60 degrees times sine of 45 degrees. Then from the unit circle, cosine of 60 degrees is 1/2, cosine of 45 degrees is square root of 2 over 2, sine of 60 degrees is square root of 3 over 2, and sine of 45 degrees is square root of 2 over 2. If we replace, we will have 1/2 multiplied by square root of 2 over 2 plus square root of 3 over 2 multiplied by square root of 2 over 2. Then we will have square root of 2 over 4 plus square root of 6 over 4. And if we add these two fractions together, we will have square root of 2 plus square root of 6 all over 4. And this is the exact value of cosine of 15 degrees. Thank you for watching all 4 examples, and please leave a comment if you would use any other methods for any of these exercises. And if you liked my explanation, please give me a like so that more people can see this video. Thank you.